Good morning, friends. This is Shivakkumar again. And as a part of instrumentation engineering details for the instrumentation and control or instrumentation, electronics and instrumentation students or EC or Triple E or say what any other electronic instrument or process control system engineers, right, or production engineers or manufacturing logistics engineers. Actually, this paper will be more useful. So this is about process control system components, right? So we are in this process control specialization instrumentation. We are studying about orifice meter. So design of an orifice for a given flow conditions, and then design. I can say design of rotameter design, and then RTD measurement circuits, design of cold junction. I can say cold junction. Compensation circuit for thermocouples. So using RTD, how you are measuring the temperature, how you are using thermocouple or RTD, how you are transmitting the signals to DCS. So say I can say the transmit. RTD transmission temperature related. So transmitters having zero and span adjustment and zero and span adjustment in the DP pressure transmitters, and there is differential pressure transmitters and temperature transmitters. And then actually we are going to see about bourdon gauges, factors affecting sensitivity, design of bourdon tube, design of air purge systems for level measurements, and then electronics based I can controllers, P controller, I controller, D controller, PA or PD or PAD controllers. So we have different types of controllers, right, in control system. So those designs and adjustment of set point, and how to bias the PAD controllers and the related other controllers, process controllers and controller settings and everything. And then we are going to study about the control valves. So what are the different types of control valves? What type of valves are there? And how much? What is a durable range? How to calibrate the control valves? Say actually the design of control valves or design of actuators and positioners. So which helps the actuators and positioners which help to adjust the stem while doing the process control automation to regulate the steam flow of say boiler waters, so pressure, all these things, right? So measure the flow, everything, and position the stem, right, valve stem, and types of valve bodies, butterfly, and then say vertical, and then actually we have different types of valve, actually simple air valve. So all these things are there, right? So valve characteristics, materials for body and trim, how to trim the valve body, and related material and design for the valve, sizing of control valves, selection of body, materials and characteristic of control valves for the typical applications, and then type of pumps and pump performance, and then pipe work calculations. So these are very important actually for an instrumentation engineer. Piping and instrumentation is very important, as I already told actually. So that is what I'm trying to say. How to type of pumps, then pump performance, and then I can say pump constructions, pipe work calculations, characteristic of different pumps, pump operations and maintenance. And then normally O&M, in power plant they are calling operation and maintenance called simply O&M. So instruments used in pumping practices, pump noise and vibration, and so selection of pumps to particular process. Say high pressurized or high viscous or chemical valves, and high caloric, high concentric fuse valves. Then we have different types of chemical and all the materials, right? So based on that, how you need to characterize all these things. So those are the important thing actually you need to design on the on this phase of the pumps and valves and control valves, actuators and everything. And then piping and instrumentation. For an instrumentation engineer, you need to be more thorough on piping and instrumentation related works and everything. So otherwise, actually, I mean, you need to properly calculate the how much pressure this particular line will handle, how much pressure this particular control valve will handle. So when if you are sending any corrosive or erosive fluid, actually will it affects the wall plug or wall stem or anything actually. So inlet and outlet and everything, right? So those things actually you need to discuss on all this part of I can say actually this piping and instrumentation related and control all instrumentations for measuring and controls of flow of fluids and streams and everything. So not only for, I mean, I can say not only for, acids and all these things. Actually, for any boil, I mean, hot waters and everything, right, in a power plant or any chemical dosing measurements and everything, right, pH meter. So all this actually we require process control instrumentation. So we have open and closed loop controllers and everything, right. So we need to design all these things, and then we have design of logical circuit and are not that is called Boolean algebra based electronic logical circuits for alarms and say annunciator circuits and interlocks. And then we have design of microprocessor based systems for data acquisition, design of microprocessor based PID controllers. So actually here only we are having in process control, we are having the programmer logic controls, and which are based on the ladder logic, right? The programming of PLC programmer logic control for process automation, right? Actually for measuring the speed or temperature or a pressure. So all these local equipments like thermocouple, RTDs, pressure transmitters, and then actually the level transmitters, flow transmitters, temperature transmitters, or measurement equipment can be say at a local point. Actually, if you are planning to use a PLC kind of control, then actually you need to have a digital relays, digital on-off switches kind of thing. And say if you then actually again if you are ready to spend on DCS, so where the central control room people are sitting, so from where they are controlling the local process, either boiler or turbine or any process industries related. So these PLCs will be again connected to the DCS, and then actually the DCS will be the distributed control system or a main control system, where actually the plant operators will be located, and they will give control by seeing the monitors, because these DCs are connected to the consoles, right, actually. So using the network technology, actually the client server technology, actually they are seeing all the actually the process locations. They say boiler instrumentation or turbine instrumentation, at what point the control is there, at what position is there, how much percentage is open, and what is the temperature of the particular boiler feed pan, or actually how the cold rate feed is done. So say how the steam is, how much percentage of steam is generated at each point of the turbine, and so each stage of the turbine, how much pressure or temperature is maintained, and thrust, and then actually say we have throttle valve control, how much percentage is open to allow the steam. So everything actually, even actually in actually the I can say the distribution side also, we have this SCADA and all these things actually, which controls the rate at which the megawatt is transmitted through the grid and everything, right? Actually, even from plant to other local grid, it's like a kind of power plant. I can say power plant supply chain actually. So from the plant, they're producing the power and then sent to the local distribution centers, right? Actually, and then grid centers, and from either it is connected to a national grid or a state grid. So which is if it is in within the TN, it is controlled by the Tamil Nadu Electricity Board. All these people are doing this kind of arrangement. And from the dispatch center, load dispatch, we have within TNB, they have load dispatch center. From load dispatch center, they will supply the power to the local public or local community, right? Actually, the people. So the local TNEB stations will monitor the amount of consumption, and they are preparing the bill, right? So these are the important things for process control. And important books I like to suggest is N.A. Anderson, Instrumentation for Process Measurements and Control, Chilton Company, published in 1980, and D.M. Coincident, Process Instruments and Control Handbook, published by McGraw-Hill Book Company in 1985. And we have these are the textbooks. And when we are coming to the references, we have Orange Waring, Pumping Manual, Gulf Publishing Corporation, 1984, and J.B. Bentley, Principles of Measurements Systems. So Longman Incorporation, 1983, and then J.P. Johnson, Process Control Instrumentation Technology, Prentice Hall Incorporation, 1980. So these are the reference book. I hope the details I have given here, right? Actually, see, because actually for PAD and PA or PD or PA, for the controllers, we need to tune that. So whether it is a closed loop, normally this filters can work on closed loop, so we need to tune accordingly, friends. So lot of information is there, but I have given a very high level overview. I am not going very deeply into that, but I hope this details will be more useful for the students, not for the experts, they know already, but for those actually students it will be very useful. So try to concentrate if you are trying for process control instrumentation field, you need to study this type of areas, right? Thanks, friends.